Hi, welcome to Algebra 2 Common Core. Today in lesson number 3, we're going to take a look at a new notation called summation notation. We're going to be using a Greek letter of the alphabet. In fact, it's the 18th letter of the Greek alphabet, and it's called sigma. So that sigma symbol looks like this. It looks kind of like an E with pointed sides on the left. Now, let's look at the notation for sigma. On the bottom, underneath the sigma, we will see an index. The index can be any lowercase letter of the alphabet. I'm going to refer to it as I right now for index, but it could be an N or a K or a J. That will tell us our beginning value for the variable. So again, this number right here is going to tell us the beginning value. On top of the sigma, we'll have a number n, and that number is going to tell us our ending value. So sigma means use all the numbers between the first beginning value and the ending value as your index. We'll be substituting that into our function for whatever the index variable is, in this case, I. So let's take a look at how this sigma works in math. Sigma means take those numbers and add them all up. So it means find the total of the values. So looking at my first example, I've got I equals 3 up to the number 5 of the function 2i. So I am going to start by taking the I value of 3 and substituting that in for I. I'm going to keep substituting numbers in until I get to I equals 5. So I'm going to say that the first value of I is 3, so we're going to substitute 3 in for I, so we'll have 2 times 3. I'll add that answer to what I get when I substitute the next value of I in. So when I is 4, I'll have 2 times 4. And the last value for I for this example will be 5, so I'll have 2 times 5. Find each of those answers, so in this case 6 plus 8 plus 10. And I'm adding these answers together because the sigma symbol means add up. So this total gives me 24, 6 plus 8 plus 10. Now our function can look like anything, and our index can be, as I said, any letter of the alphabet, usually a lowercase letter, and our index can begin and end at any whole number. Actually, I guess it would be an integer because indices can also be negative. So let's go on to part B. K starts at -1 and K goes to the number 3. I'm going to substitute K into the function K squared. So I'm going to say the first value of K is -1. Let's square that. The second value of K, count up, and I get 0 squared, then 1 squared, then 2 squared, then 3 squared. I know to stop at the number 3 because the upper limit is 3 right here on top of the sigma sign. Evaluate each of these, so I've got 1 plus 0 plus 1 plus 4 plus 9. And when I add all of these together, my total is equal to 15. So the summation of the terms K squared from K equals -1 to 3 is 15. Let's try C. This time my index is J. J is starting at -2 and going to 2. So the function says to use J as my exponent. So we'll have 2 to the -2 plus 2 to the -1 plus 2 to the 0 plus 2 to the 1 plus 2 to the 2. Evaluate, so I've got 1/4 plus 1/2 plus 1 plus 2 plus 4, and when I added all that together, I got 7 3/4 for the total. So again, sigma means find the sum of those terms. Let's try a couple more. So I starts at 1 and goes to 5. My function is negative 1 to the I. So negative 1 to the first plus negative 1 to the second plus negative 1 to the third plus negative 1 to the fourth plus negative 1 to the fifth. So negative 1 to any odd power is going to give me negative 1. Negative 1 to any even power is going to give me a positive 1. So I'm adding together the terms negative 1 plus negative 1 plus 1 plus negative 1. And I see that there's one extra negative 1, so therefore my total must be negative 1. Take a minute to try the next two examples and then come back and check your work with mine. Welcome back. Did you get 9 for E and 20 for F? I listed down each term in the summations and then I added those terms together. If you have any questions, come and see me. Let's try exercise number 2. Which of the following represents the value of the sigma from I equals 1 to 4 of 1 over I? So I'm going to substitute all of those values for I in, so I'll have 1 over 1 plus, then I becomes 2, so 1 over 2, then I becomes 3, so 1 over 3, plus 1 over 4. And sigma is always going to mean to add together, so I'm going to total those together. When I add these together, I do have to use a common denominator. So I've got, probably 12 as my common denominator. So 12 over 12 plus 6 over 12 plus 4 over 12 plus 3 over 12. And when I add those together, that looks like 25 over 12. So my answer, choice 3. Now, sometimes we'll have to figure out what the terms are before we go to our sigma. So if I look at this next example, I see that my sequence is defined by the recursive formula an equals the previous term an minus 1 plus 2 times the term even previous to that, an minus 2. I've got that a1 is 0, a2 is 1. So I'm going to start listing these terms down. a1 is 0. A2 is equal to 1. Let's go ahead and use the recursive definition to find the next terms. We see by our sigma that we have to have the fourth term all the way to the seventh term. So A3 is just going to be equal to the previous term 1 plus 2 times the term before that, so that gives me an answer of 1. A4 will be equal to the previous term plus 2 times the term before that, so that's equal to 3. A5 will be equal to the previous term 3 plus 2 times the term before that, so that's 5. A6 will be equal to the previous term 5 plus 2 times the term before that one, so that gives me 5 plus 6, 11. And A7, the previous term 11 plus 2 times the term before that, so that's giving me 21. Now I want to add together terms 4 plus 5 plus 6 plus 7. So that tells me add together 3 plus 5 plus 11 plus 21. So I think that gives me a total of 40. In exercise number 4, we're given a summation and we're asked to figure out which sigma stands for that summation. So we're going to have to expand each of them and see which ones have terms that match the given. So for number 1, I see that I'm starting with I equals 1 and going to 5. And my function is 3 to the I. So this would represent 3 to the first plus 3 to the second plus 3 to the third all the way up to 3 to the fifth power. Now if I evaluate those, that gives me 3 plus 9 plus 27 plus 81 plus 243. Clearly not the numbers that I wanted to add together, so I'll cross that one off. Let's try choice 2. We're starting with I equals 0, so I'm going to say 3 times 2 to the 0 plus 3 times 2 to the first plus 3 times 2 to the second plus 3 times 2 to the third plus 3 times 2 to the fourth. So 2 to the 0 is 1 times 3 gives me 3. 2 to the first is 2 times 3 is 6. 2 to the second is 4 times 3 is 12, and this starts to look kind of promising. 2 to the third is 8 times 3 is 24. And 2 to the fourth is 16 times 3 is 48. So I think we found the right match. Let's just take a look at what the other two would represent. For choice 3, this would be 6 to the 0 minus 1, so 6 to the minus 1. Then I'm going to put a 1 in for I, so 6 to the 0. Then I'm going to put a 2 in for I, so 6 to the first. Then I'm putting a 3 in for I, so 6 to the second. And then I'm putting a 4 in for I, 6 to the third. So clearly I would have 1/6 plus 1 plus 6 plus 36 plus 216, and that is also not the right match. The last one looks a little unusual. I'm starting with I equals 3, and I'm adding up all the way to I equals 48. That's going to be a whole lot more terms than what I was given. Just to get an idea of what the beginning looks like, though, it would be 3 plus I would be 4 plus I would be 5 plus I would be 6, and I would keep going all the way till I got to 47 and then 48. There would be about 45 terms that I would have to add together, so that one doesn't match either. Now let's practice writing a given sum in sigma notation. So it's going to be important that we have all parts of our sigma in the answer. So I'm going to say sigma. You can pick your index. So for the first one, I think I'll pick K. Now when I look at this, I notice that the terms seem to be the powers of 4. So the first one is actually 4 to the 0 power. Then 4 to the first, 4 to the second, 4 to the third. Let's see here, 256 would be 4 to the fourth, 1024 would be 4 to the fifth. So this last one looks like 4 to the sixth power. Pause the video and check on your calculator and make sure that those exponentials make sense. So my K, the thing that's changing as I go from term to term, is the exponent. The exponent starts at 0 and goes all the way up to 6. So I'm going to say that my function is 4 raised to the K power. If I just try that out, I'm going to have 4 to the 0 plus 4 to the first plus 4 to the second plus 4 to the third plus 4 to the fourth plus 4 to the fifth plus 4 to the sixth. Does that match what we're given? 1 plus 4 plus 16 plus 64 plus 256 plus 1024 plus 4096. So our answer would be this sigma notation right here. Let's try B. So we're going to make a sigma. Let's try a different index. What if we call it I? So looking at the terms, I see that all of them are over the number 2. So I'm going to put that in my function. The top numbers, if you look carefully, notice that they're all perfect squares. So the first one would be 1 squared, then 2 squared, then 3 squared, 4 squared, and 5 squared. So what's changing here is the term that's being squared. So I'm going to call that I. So I've got I squared over 2. I begins with the number 1 and keeps going to the number 5. So our sigma notation for this sum would be sigma from I equals 1 to 5 of I squared over 2. Please add these 2 practice problems to your notes on page 6, and then try both of them and come back and check your work with mine. Welcome back. Check each of your terms. Make sure that you've added together the right number of terms. I got for my total for the first one 123, and my total for the second one 110. Thanks for practicing with Sigma tonight. Have a great night, and we'll see you tomorrow.